this video, we're going to look at breaking down the NGSS standards as they're written and what information is in each little part of those performance expectations. Also, ways that they're built to allow you to bring in cross-curricular stuff or just to picture the overall learning environment of the student and how you can pull it all together. So it makes sense if we go back in time, compare it to the standards that you may have used before your state adopted NGSS. So these are the old standards on, in this case, chemical reactions. So in this case, these are the facts that students need to know about chemical reactions. So understanding types of reactions, a synthesis or decomposition or combustion reaction, what those mean. Why do students need to know that? What are they going to do with them? I don't know. If you as a teacher had trouble answering those questions, it made it harder to teach. So the next generation science standards were organized quite differently. On the website, most of what they do is try to sell the standards to people and explain why they're not a dumb idea, or explain how they came about and why the people who built them know what they're talking about and how it's not a dumb idea. When you actually look at the standards page, a lot of this information on the site is kind of similar. It's really a good resource after you maybe get first exposed. You're going to have questions like, what's the difference between a science practice and an engineering practice? Well, on the side it explains it. If you're first diving in, though, it might be good just to look at the standards and play around and compare them to what you previously used. Let's look at the disciplinary core idea first. So let's compare the high school chemical reaction standards to what they used to look like. First off, it's matter and its interaction. So the first half is just talking about atoms, periodic table. Then that moves to how the different elements combine, and we look at what the students are going to be able to do when they understand about all of those facts. So originally, they just wanted us to know facts, not necessarily do anything. Now, what they're assessed on is, could they develop a model to illustrate an aspect of a chemical reaction? Could they provide evidence and an explanation about a chemical reaction? Could they refine the design of a chemical reaction in order to make something happen? Where's the content, though? Well, that is at the bottom. So the disciplinary core idea, what these are arranged by, you have a section on chemical reactions, and that section outlines what are the facts that students need to be able to know in order to do those performance expectations. Now, in addition to the core ideas, you also have the science and engineering practices and the cross-cutting concepts. These are the three areas on which the NGSS standards are focused, because the people who develop these realize all science and engineering, they use models. They use them in different ways, but they all use models. They perform investigations, they use math, they explain things and design solutions. So whatever topic in science, whether it's ecosystems or chemical reactions, all of these things should be happening. And if students can't perform these things, they're not getting out of your class what they should, regardless of the content. The other thing is cross-cutting concepts, kind of a nebulous ideas that are pervasive in all areas of science also. So patterns, the flow of energy and matter, stability and change, these things show up in biology or physics or earth science, whatever category of science you're looking at. Now, if we actually look at these standards themselves, one really helpful way to look at these is to use these different options at the top. If you click practices and core ideas, the practices, the performance expectations, basically, that's the verbs, the things students are doing. So they're going to build a model and predict. They're going to construct a plan. They're going to conduct an investigation. The things students should, at the end of your course, be able to do. These aren't the lesson plan ideas for you. This isn't how you'll get them to understand things. This is what they need to do at the end. It's up to the individual teacher to decide how that will happen. Now, those are color-coded. The practices are color-coded blue, just like the box at the bottom. The disciplinary core ideas are colored orange, just like at the bottom. And you see if you hover over these, you have more in-depth explanation of them, which is the same as written in the blue box or the orange box, but it keeps you from having to scroll. The other option, I like this one best because it gives you 3 colors. It highlights the blue practices and the green cross-cutting concepts, and then the core idea is basically the black part. You also see clarification statements under most of the standards that give you some examples of where they're going with this, or put it in less clinical terms in some cases. Many of the performance expectations also have assessment boundaries, and these are important to teachers because it tells you, well, how much the students really need to know at your level. So at middle school, even though you know there's deeper stuff they should be learning eventually about chemical reactions, not at the middle school. If you have students who are ready to look past the main group elements, they want to look at properties of the weird stuff that's in the corners of the periodic table, they can. You should strive to have your students do that. Your high school chemistry teacher will love you for it. But not all of the students need to be driven that far. The intent isn't to dumb down the content or to water down your expectations. The intent is just to say, this is the level that we're assessing at. If you go higher, super. But you don't have to kill yourself trying to get the whole thing into an 8th grader. Now, we picked the disciplinary core idea arrangement. So these are all the core ideas relating to matter and its interactions. So these are just listed out as matter number 1, matter number 2, matter number 3, all the way down. But if we went back and we, instead of going to the disciplinary core idea arrangement, if we selected the topics arrangement, in a high school chemistry class, you're not going to bundle matter in the periodic table all together with chemical reactions. You're going to separate it out, and that's what happens here. There's matter, and then there's chemical reaction. So after the creators of NGSS made the content standards according to the content and the performance outcomes for students to demonstrate their understanding of the content, they thought, okay, but teachers aren't necessarily going to teach it in those chunks. How would teachers teach it? They're going to flow things together a little bit. They're also going to look over at the math class or the earth science class and see how those things fit into it. And so they broke it down into topics. So as a teacher designing your course, I would suggest the topics view. It's a suggestion for your course. It's not a mandate or a outlined curriculum for you. They intentionally didn't make a curriculum because they want teachers to do what works for your class. Here, looking at structure and properties of matter, instead of the idea of content area 1, which was matter and reactions, you just have 1.1, 1.3, and 1.8. So it really jumps around. And then it jumps all the way to 2.6. So that's a category we didn't even look at before, but it fits with matter. So when we look at chemical reactions, the missing standards from the earlier topic of matter, they show up here. So 1-2, 1-4, 1-5, 6, and 7. Now the other things, like I said, you're going to peek at what math is doing, what earth science is doing, and see if those things fit as well. And that comes a little bit lower. So underneath the information about this standard, these are connections to other things in this grade level. So chemical reactions are also going to be related to, and we can click on this, they're going to be related to these energy standards. They're going to be related to a life science standard, looking at molecules and organism structure and processes. So when plants undergo photosynthesis, students need to know about chemical reactions. So maybe you can work out something with your biology teacher to coordinate something there. You also need to know what students got before this about chemical reactions and where they're going next. So the articulation of DCIs across grade bands, clicking on each of these will take you to those middle school standards because you should know what the students are bringing in. You can also look at the Common Core standards. So while students are doing these really good performance assessment items and they're making arguments, well, how do the arguments my students are making fit with what they're learning in their English class? And this outlines what they should be learning at the same level. Same thing with math. So if you know what they're doing in English and what they're doing in math, you can help the student as a whole get better. And it's a lot of information on these pages, but the intent is we're looking at the big picture. We're not looking at just your tiny topic and your tiny facts, because these standards don't really do a lot to develop a student who can perform. So now that you've actually finally found the standards and you've looked through and you understand how the pieces of the actual standard as it's written fit together and all the other information that you're able to bring in, now it's time to start developing them. So jump in, start thinking about how you can build your course to have students reach those performance expectations. The next video will be talking about these appendices on the side, which give a lot more information and have lots of handy little tools and tables to help guide you in that process.